we've spent our time talking about functions of two variables, but we want to talk a little bit about functions of three variables as well. So if I have a 3D function, f of x, y, z, then I can say that that function is continuous at some point x0, y0, z0 if the function, first of all, is defined at that point, and the limit of this function as the ordered triplet approaches that point is equal to the function value at that point. So continuity is all, we always use this limit idea to define continuity. And if we want to discuss the continuity of something like 1 divided by x squared plus y squared minus z, well, again, that's that f divided by g, and we know that f is 1, so that's a constant function, doesn't really do much for you. But that g function, x squared plus y squared minus z, we just need to guarantee that's not equal to 0. If there was like a square root or a natural log or something, we might need to think a little more about it, but we need to find out where this thing's 0 because it's in the denominator. So what we're really trying to say is x squared plus y squared minus z can't equal 0. But if we do that, we can kind of treat it like it's an equal sign. So with a little bit of algebra, what we get is that z can't equal x squared plus y squared. So if this was z did equal that, then we could get a graph that looked like this. This is a paraboloid. So if this was z squared over here, it would look like a cone. But instead, the z, y, and zx plane, those traces of cross sections are just parabolas. So there's a parabola here and a parabola there, and I'm drawing these kind of ellipses around them to chain them together. And what you're really saying is that the function is continuous everywhere but this parabola. So you could take, but this paraboloid, you could take any point anywhere in the space except for the points on the paraboloid, and the function would be continuous. So we would say, continuous anywhere that does not hold. And ultimately, the process is pretty much the same as it is for two variables.